The most important part, without any doubt, is seeing the motion. And here's what's crazy about this thing. A lot of people get to this section and it's like we never went over chapter 1 at all. When I say seeing the motion, I really typically mean a motion diagram. And not everybody sees in motion diagrams, and I'm totally okay with that. The other way that you can actually see the motion here is to actually look at the plots. And when I think about plots, I think about something like this here. I think about plotting velocity versus time. By looking at the velocity versus time, you can easily see when you have intervals of acceleration. And the whole goal is for seeing intervals of acceleration. Now, when it comes to quizzes and exams, people who see the motion do well. And what I mean by see the motion, that means that in some shape or form, you're drawing a motion diagram. In some shape or form, you're plotting velocity versus time or all of the motion. And what you find here is that there are people that go and take the quizzes that say, well, I don't need those motion diagrams. Those were kids' pictures. Well, I really didn't understand the plotting of position, velocity, and time and acceleration. So I'm not going to do those. I'm just going to go for the equation. Well, I'm going to tell you right now, good luck to you. My experience is that people that do that do considerably worse. And when I go and I grade the quizzes, I actually typically do counting. I go like, okay, who drew it, who didn't? Because there's going to be a point where I'm going to say, you don't have to draw a motion diagram if you don't want to. You're an adult. You do what works best for you. But the people that continue to do this or this and have some strategy are the people that are successful here. And believe it or not, all I care about is you understanding what you're doing and you're moving on. So don't forget about chapter 1. It's kind of crazy. Didn't we do all this shit right now? I mean, make it to your advantage. I mean, I'm not here to lecture you, even though I'm probably lecturing you right now. But just remember, there's a reason why we did it. So that being said, what I want to go do here is that I want to go into the details of the mathematics. The crux of everything is the picture. Because the mathematics is fairly simple. They're simple algebra equations. But you know how many times I'm going to hear the story? I understand everything that you say, but when I get to the homework, I can't do it. Go back to chapter 1 and figure it out then. That's why we did it. The mathematics is simple. Okay, that being said.
Quick question. On like a quiz or exam, our motion diagrams don't have to be like great looking, right?
They don't. And you're going to, and you know what you're going to see is that I'm even going to reduce the motion diagrams.
Okay.
And we're only interested in identifying intervals. That's all what we're interested in. I don't care about anything else. It's the intervals, and it's going to simplify them a lot more. So
okay, thanks.
Okay, so here we go. Let's go do this. So this is a strategy that I kind of borrowed from here and there. It's not mine. I saw somebody lecture about this when I was at a physics conference, and I says, wow, that's a badass technique. So guess what? It's mine now. Okay, I've modified it, and I tried to organize it to the best of my ability. So our goal here is to master these 4 equations. Can I derive them? Oh yeah, they're easy to derive. So what I want to do here is that I want to go through a systematic way of knowing when to pick the right equation for this. And so what you're going to find here is from your picture, I'm going to try to get you to organize your information and then show you how to pick the correct equation. So since these are the 4 equations, one of the things that I want you to pay attention to here is look at this first equation. This first equation that says V equals V initial plus AT. Now, it turns out that there are 5 different variables, okay? 5 different variables. Note that there's one variable that's missing here. It turns out to be displacement. Now, if I go to the second one, the one with the velocity squared term, what you're seeing here is that I got velocity, initial velocity, acceleration, and displacement. Note that there's one variable missing, which is time. So when you look at these 4 equations, they have one crucial parameter that's not there. So here's the goal here. What is our goal? If we know 3 of them, we can calculate the 4 of them. So what I say here is that one way to organize information is to create these things called data tables. And what it does here is it allows you to come into this table here and put in your position, your acceleration, your velocity, your initial velocity, and time. It clearly defines this. And here's the crazy thing. It's the thing that you don't know tells you which equation you got to use. The thing that you're missing. So for example, look at this first equation. What's the parameter that's missing? It's delta x. So if you know that you don't have delta x, then you know which equation to actually use. So what we're going to do here is that I have this thing called the kinematics variables table. And the idea here is that if you look at the first equation, you could see what's missing, delta x. So if you set up your data table here and you put an x here saying that in the problem, there's no delta x, guess what? It's not rocket science. You go, this is the equation I got to use right here. And if you look at this equation, what's the one thing that's missing? Is time. So if I set up my data table, my missing time, I know this is the equation I got to use. There's no choice. And I could go on to this one. So what's missing from this equation? The final velocity. What's missing from this equation? The acceleration. So these equations have some way of systematically understanding them and learning how to identify from what the data tables, what you're missing, then tells you which equation it is. I'm not so much interested in the mathematics. I'm interested in the physics. So now I see it as a crank. Now we got a crank. All we do is that we systematically set up data tables, pick the right equation, and then we solve the equations. All the physics is done when you draw the picture. So here's my process then. So my strategies are, I'm going to applying the kinematic equations is that, what do? Look what I said here. Draw a picture. What's the crux of this whole problem solving strategy? Step number 1, without any doubt. If you don't understand 1, you can't solve the problem. And then step 2, define the direction of motion to always be positive. Let me ask you a silly question. If you're driving towards Santa Cruz from Aptos, are you driving in the positive or negative direction? You probably don't even think about it. But we're just saying, yeah, that's my direction. So mathematically in our head, we're probably saying that's the positive direction. if you're now driving from Santa Cruz back to Aptos, are you driving in the negative or positive direction? You don't think about it. Always pick your velocity to be in the positive direction. The direction of motion is always the positive direction. And if you do that, you'll see it's going to be much, much nicer to do that. And then 3, I say, once you got the picture, you've now set your sign convention for your problem. Then I say, create the data table and make sure that they all have the proper units, meters and seconds. Once I have that, then from the data table, what I don't know, I use the kinematics table to do what? Select the correct equation. And once I got the correct equation, I now go solve for the correct variable. Okay? So the whole goal here is that get the picture and the direction. Once you get the picture, set up a data table, and then use the kinematics table to pick the right variable, and then do the mathematics to solve for the correct variable.